Okay, so let's do a lot of integrals that look like this here. And why don't we use the method called U-substitutions? So here's the idea. If you observe the problem here, you'll notice that if you look at this there, the derivative of that is like 21x squared minus 6, which you can see up there. That indicates that this there is what you should let u equal. So what we'll do here off to the side is we'll let u equal 7x cubed minus 6x. Not the 8. No, no, leave that there. Just the stuff on the inside is what u will be. Now, here is your u equation. Take its derivative. So the derivative of u is what we call du. Now, the derivative of this is going to be, well, let's see, 3 times 7. Take away 1 from 3 to get 2. That's going to be minus 6. So this is the derivative, and it is customary to protect it and to punctuate it with a dx in the back. And now, if you look at the original problem, this here can get replaced by u, and the entire back portion can get replaced by du. So let's rewrite all of this. So keep the integral, and then the parentheses get replaced by u. The 8 is still there, and then everything else gets replaced by du. You have to make sure that the entire original is accounted for when you rewrite it in terms of u's and du's. So now what I want you to do is forget all of this and look only here. Worry about this integral. So what would be the antiderivative of u to the 8? Well, that would be u to the 9, and then you flip the 9 to get 1/9, and then you put your plus c. And the integral symbol is gone from here to here because you found the antiderivative. And now to finish this problem, write this again, but instead of u, you fill it in with the stuff with x's. So final answer, 1/9, and then the stuff that you equaled to the power of 9 plus c, box that in, 100%. Yeah, that looks good. So let's try maybe 3 more here. So what about this one? The integral of, let's say, e to the power of sine x plus 7x, and then times by cosine of x plus 7 with a dx in the back. And so analyzing all the information, I would allow u to equal only the exponent in this case, not the e. No, no, just its exponent in this case. Because if this is our u, then our derivative du would be, well, the derivative of sine is cosine, and the derivative of 7x is just 7. And that matches perfectly with what we have back over here, right? It matches perfectly. So let's rewrite the original problem in terms of u's. So we have integral e to the u du. And then look at your cheat sheet. And e to the u, the antiderivative of e to the u is e to the u plus c. And that's it, right? Just the u gets replaced by sine of x plus 7x, and then plus c. Done, done, done. All right, let's try a couple more here. What about something with exponentials? So let's go integral. Let's go 80x, and then let's go times 5 to the power of 4x squared minus 6. So here, deciding on u, well, I do notice that this is x squared, and I do notice that this is x1. So I am going to attempt to let the u be the thing that has the x squared. So like the whole component, 4x squared minus 6. So then du would be 2 times 4 is 8x dx. But if you compare this with that over there, it seems like it's not right because this says 80 and this is 8. So the trick is this. Here in, let's go with green, what we'll do is we'll multiply this by 10, but you'll have to multiply this side by 10 as well. So that would become 10 du equals 80x dx. And so the original problem, let's see, this should have been a dx there in the back in the original problem. Oops, there it is. So let's see. So the original problem, the 5 is there, and its exponent gets replaced by u, and this component combined with this part get replaced by 10 du, right? Everything has to be accounted for. The 5 is there, the whole power is u, and then the missing pieces, or this piece combined with this piece there, get replaced by 10 du. So now looking here, what we can do is maybe we can take the 10 to the outside. Let's get rid of the 10. If you're wondering, the 5, you cannot take out the 5. No, because the 5 has a U. It has a letter attached to it, right? It has a U. So not the 5, but the 10, yeah. The 10 for sure. So now here, leave 10 alone. And then look at your formulas to give me this antiderivative. And if you look at your cheat sheets, the antiderivative of this should be 1 over natural log of 5 times 5 to the U plus C. And that'll be your answer. But of course, instead of U, you want to write the value of U. So let me just make that changed real quick. This would be 4x squared minus 6 plus C. Let me just bubble this in. So you could leave your answer like that. Looks pretty good. And let me take a quick look at this. Yeah, that looks pretty good. Yep, leave it like that. All right, so how about we try one more problem? Let's get rid of all of this. Let's do one with, let's see, how about this one here? Let's go integral of, let's say, 10 over parentheses 5x plus 2 to the power of, let's say, 1/4 dx. Let's see how this one goes. Last one for this video. So why don't we let u equal 5x plus 2. Then du would be 5, and then that's pretty much it, right? Just 5, but you want to attach a dx. And notice in the original problem, there's a 10 dx, right? I mean, you could put the dx up here in the top if you want and just get rid of it. Same thing, doesn't really matter. But this says 5 dx and this is 10 dx. So we'll multiply this both sides by 2, so that 2 du is 10 dx. And now we can rewrite the original problem. So we have integral, and the numerator, 10 dx, gets replaced by 2 du, and the bottom would be u to the 1/4. Now, why don't we move the 2 to the outside and move the du sort of attached to the hip? So we have 2 integral 1 over u to the 1/4 du. And then why don't we bring the u's to the top? Let's continue here. So we have 2 integral u to the negative 1/4 du. And I move it to the top and the power becomes negative. But the reason I did that is because if you look in your formulas, we can use formula number 2 on this integral right there. So here's what this would look like. Keep the 2 on the outside as is. Now, to find the antiderivative of this, keep u there, but then add 1 to this. Take negative 1/4, but then add 1 to that. And if you add 1 to negative 1/4, you get positive 3/4. That's the new power. And then take the new power, reciprocate it, and put it before the u. And then plus c. And then how about we go 2 times 4? So that's 8/3. And then we have 3/4 plus c. And then, of course, instead of u in there, you drop in what u equaled. And we're done.